So let's talk about the substitution ciphers. We have already seen the substitution ciphers substitutes the plain text characters by some other characters. So the characters of plain text are substituted by another characters, and the weakness of the substitution ciphers are can easily be brute force. So you can try all the combination of substituted characters and you can get a meaningful plain text in one attempt, and the advantages can easily be encrypted. So let's see some examples of the substitution ciphers to get more idea about this. So first one we are going to see is the Ciphers cipher, and this is the very basic cipher you will come to know when you're starting cryptography. So what the cipher does is you need to write down all the alphabets, and these alphabets contain some indexes. So A is 0 index, B is 1 index, and so on up to Z is 25 index. So we have indexes of A to Z are from 0 to 25, 0, 1, 2, 3, 4, 5, 6, 7 and so on up to 25. So if you have a plain text and you have to apply character wise. So you take the first character and find out that index. So after finding that index, you need to determine some key. So this is where you need to determine some key and you need to add that index to it. So index plus key, you will get some value, and what you want to do is you want to modular division by 26, because if the value of index is like 20 and if value of the key is 10, it will go outside of this table, right? Because the limit is 25 and we get 30 on addition. That's why we need to modular divide 26 such that we only consider the remainder of this division. So first we take the index of an that character in the plain text and we manually determine some key, and then we add that index and key, and then we modular divide with 26, so such that the cipher text will be only in this range. So let's take a look at this example. So this is the table. 0 contains A and 1 B, 2 C and so on up to 25 means Z. So I'm going to take an example. The plain text is AMTYZ. So think it as an abbreviation, and now I have already determined the key is equal to 6. So we need to do the Ciphers, apply the Ciphers cipher for each and every character. Let's take A. So in the previous table, let's find out the index of A. So A is at the 0 index, and you need to press 0 plus the key, which is 6, and modular division 6. 0 plus 6 gives 6, and after division with 26, 26 goes in zeros, and then remainder is 6. And the value, if you take a look at this 6 in the table, you get the value as G. So write it down, G. So our A in the plain text has been converted into G in the cipher text. In the same way, you take M. The M's value is 12, and then you add 6, which gives 18, and then modular 26. Since it's less than 26, 26 goes 18 in 0 times and leaves the remainder 18. So the answer is 18, and if you take a look at the table, the 18 value is S. So you write it down. So instead of M, you are keeping S. In the same way, you can do the every other letter. Let's take a look at this Y. The index of Y is 24, and if you add 6, you get 30. So our boundary has been exceeded. So the answer got over the 25. So that's why we will do the modular 26, because we get only reminders from 0 to 25 if you divide with 26, right? That's why we will do the modular division 26. So 30 modular division 26, you get 4. So 26 once is equal to 26, and plus 4 gives 30, right? And 4 is E. In the same way, Z's value is 25, and then if we add 6, we get 31, and if you modular divide by 26, you get 5. The value of 5 is F. So in that way, we get the cipher text finally as G, S, Z, E, F. So instead of A, we are writing G. Instead of M, we are writing S, T, Z, Y, E, and Z transforms to F. So final cipher text will be G, S, Z, E, F. We send the key also to our receiver, and then he just adds minus in the same way to get this plain text. he put the minus and do the modular division, and he get the value of the plain text. So this is one of the example of the ciphertext. The weakness lies because the keys, maximum keys if you can produce, even though if you put the infinity, this modulo 26 gives only the 25 possibilities, right? So you can just apply the every key to this plain text, and you can generate 25 different sets of ciphertext. In those 25 different sets, one set will be the meaningful, because our plain text will be meaningful. I took just this an example to show you the starting letters, middle letters, and ending letters. So in reality, the plain text will be the meaningful. That's why hacker will use this. If he knows the key, and if he knows that we have used the ciphertext, he simply brute forces and he gets 25 results. In 25 results, it's easy to find out the meaningful sentence, right? That's why Caesar cipher is easily brute force. And next example we are going to see is Vignere cipher. And what we are going to do is, we are going to create a table, and the rows and columns are created by alphabets. You need to create a table with the A to Z, and the rows and columns should also be the same, and key should be exactly same length of that plain text. So if the plain text contains 10 characters, the key should be also 10 characters. If not, repeat the key up to the length of the plain text. That means if the plain text length is 10, and if the key is 4, you need to repeat it again 4, and you get the key as 8. So you get the remaining 2, right? That means you need to fill up 2 more characters, and you can just repeat the 2 more characters of the key. So that's how you make sure that the exact the plain text length and the key length are equal. And now mapping should be done between the plain text alphabets column and the keys alphabets row. So you take each alphabet of plain text, and you consider the column of that row of the table and the key alphabets row, and after the mapping you will get the one value, and that value is the ciphertext. So let me explain. So this is the table. I have taken this photo from the internet, because I cannot create this in the PPT, this much large table. So we have rows A, B, C, D, E, F, G, H, I, J, and to Z, and here columns A to Z. Now let's take an example. So plain text Nikhil. So okay, this is my name, and the key is high, HI. Since the key's length is less than plain text, we need to repeat the key. So what we are going to do is, we need to put HI. So in this case, we got the exactly the 2 multiples. If you have Nikhil 2, you need to Nikhil A, you need to put H here. You just simply repeat until the plain text characters are equal to keys length characters. So first I want to take this first alphabet N, second alphabet H. Look at the nth column. So okay, in this nth column I need to look at the H row. So nth column and H row. So nth column, so nth column H row. So I take this nth column and H row. So it is U. So my plain text character N will transform into U. In the same way, ith column, ith row. So where is this ith column and ith row? It's Q. And in the same way, so here is Q, and in the same way, kth column and H row, and kth column H row, R. So it's R. In the same way, you can find all these, and let's see the last one, L column, I row. L column, I row, and T. So the ciphertext of the plain text Nikhil is UQR PPT. So these 2 ciphers are example of substitution ciphers. There are so many substitution ciphers out there, but I cannot tell everything. There are a lot more than expected. So I chose these 2 main ciphers because I want to show you how substitution ciphers will work and how one can brute force it. And you can also check other substitution ciphers on the internet as well. But my intention is to show you that how this substitution ciphers works. That's all for this video.